Yeah, that's what I was done. They're like, oh yeah, this is the big one. We've been in the same session every day today.
I always get that. So.
I'm going to need a yeah.
Okay, I think we can get started. Sound good, Francesca? Okay, cool. Well, hi everyone. Welcome to the OHAI session at IETF113. I'm Siobhan, and I'm joined by Richard Barnes, and Francesca is our eyes and ears on the ground. Thank you for that. And we are still looking for a note taker. So if anyone would be willing to volunteer, that would be fantastic. Anyone? Paste the link in the notes as well. I think Richard also said that he can keep an eye on the minutes as well. So worst case, we could do that, but it would be really nice if someone could just volunteer. Fantastic, thank you. So we have a note taker. Yeah, and if you have anything that you would like to say at the mic, just prepend that with Mike, and we can get that sorted out. This is the IETF Note Well. Please go through this, whether it's your first IETF meeting or your 113th. It's always good to refresh your memory. IETF 113 is hybrid, so if you're in person, please make sure to sign into the session using the Meet Echo online tool, and please use Meet Echo to join the queue. It is important for queuing, and all queuing is done through Meet Echo. All right, I think we can get started. We do have quite a bit of time, so I'm hoping we can get some good discussion done. And first up, we'll have Martin, and then there will be some discussion about issues and updates since last meeting, and then we'll have two brand new drafts being presented by Tommy and Tiru. So if Martin, I think you have some slides, if you wouldn't mind just coming up. Perfect. No, I think I have to. No.
Let's see how this works. I'm going to do the Hall of Mirrors thing for a moment, because I'm going to be jumping into, yes, I want to share my screen. That's the crazy thing. Yeah. Okay, Hall of Mirrors, and now slides. So this is just a brief update on what we're doing, and I'm going to go through some of the issues here that we've got since last meeting. There have been a few issues raised in the last hour or so. Obviously, I won't go into those ones, but I will hopefully get through all of the important things that we identified. This is every open issue that existed as of a week ago. So, option 1, changes in version 1. We've moved the padding to the binary messages draft. That is something that I think simplifies the overall design, and it makes the binary messages stuff more useful generally. We've also made changes to the labels that we're using for generating the text and the exports. Those are now based on the content type of the content that's enclosed. And there's some text about repurposing the design that we have here for other purposes. Not that this is a primary goal for us, but it's something that makes it a little bit easier for us to manage. There's some new text on resource mappings, I think one of our new issues is about that, and some draft text on anti-replay that I'll go through as part of the issues here. So the first one of the issues that we're talking about is what information the proxy is able to provide to a server when it relays messages. Obviously, we want the proxy to hide a lot of information about what the client is, who they are, and where the requests are coming from. But there are certain use cases where it might be useful, perhaps, to have a proxy provides just a tiny amount of information. At the moment, we're considering 1 bit that would allow proxies to do shadow banning, for instance. That is, identify abusive clients and allow the request to pass and appear to be handled correctly, but give the server a sort of side channel signal that says, hey, this guy's probably a bad actor. You might want to deprioritize or respond in a different fashion. There's a pull request. We're discussing that. I don't know if we want to talk about that one just now. That's kind of in flight right now. There's a number of comments. So I will probably just stick to this one here. Are there any comments about this one? I'm going to bring this off full screen.
Becker, did you want to go?
Just waiting to be called on. Yeah, so I guess I think my take on this is that actually, like, this entire restriction is kind of misguided, and that there's a number of things that you might want the proxy to say. One of them is this bit, as you indicate. One of them I've heard floated is a token of some kind indicating, there's been some sort of dial service reputation kind of stuff on it. One thing I've heard of is rough geo. I certainly heard suggestions of of short-term linkages for IP address. That this is the same person over a couple messages. I'm not really a huge fan of any of these, but I guess my general thesis is that these are all out of scope for this protocol, and that we should simply not say anything about what you should say, and leave that to applications. Fundamentally, that's fundamentally exactly what messages or what crap is conveyed in that metadata is really like for the client and the client and the proxy to like work out for themselves. I understand that, like, certainly, like, that allows you to bypass any possible protections being offered here, but this is just like a 6919 must. Like, the must doesn't stop that from happening. The must just says don't do it. So I just think it's like, rather than trying to like put that in a number of language, we should like talk about what Nick asked, will you be able to know what's being added to them? Yeah, the point is that there would be an understood policy of what the proxy was doing and not doing, and the user would be aware of that at the point they chose it, to the extent to which they're aware of anything they choose, anything here, right? I mean, the proxy and the proxy can just be side channeling all the information to the server for once, right? And so the only question here is like, so I think, like, you're fundamentally trusting the proxy to do that.
Yeah, so that speaks to potentially saying, as long as the potential range of things that a proxy could communicate to a server is known to the client, then the client can use that as part of its decision to use a proxy.
That's what I was just. That's my.
And in general, maybe we could just have some waffly words about, don't include too much. Chris.
Yeah, I think that's what the text in 96 tries to do right now. In particular, it tries to say that any of this public metadata that the client and proxy agree upon as being revealed during the course of using this proxy is known to the client. Whereas in contrast, what I call private metadata, like this shadow banning bit, where the client does not necessarily agree to the presence of that metadata, that must be strictly bounded. The proxy just shouldn't add things to the client's forwarded request without the client being aware of it. So the sort of intent here in my mental model has been that the any sort of public metadata is agreed upon between client and proxy and factored into the decision to use a particular proxy or not. And private metadata must be strictly bounded. It is sort of like a, must, but we know you won't in a way. But at the end of the day, you kind of have to trust the proxy to not do bad things like forward your IP address or whatever. So I'm not too concerned with the language there, but that's the intent. That's my mental model. So I think that aligns with Ecker as well.
So Chris, I want to pull on something there a little bit. There's two things that we're sort of conflating, perhaps. One is the spectrum of possible things that the proxy might say, so the type of information that it might pass to a server, and the other is the specific values that those types take. Yep. Are you suggesting that most things fit in the precise value that's being communicated, or is that just all of them just the type of the thing that's being communicated about you?
Can you repeat it one more time? I'm sorry. I just woke up.
So in understandable. So in the shadow banning case, the client might know that the proxy might pass a bit along, but it won't know the value of that bit.
Yeah.
In the geo case, do we expect that the client will know the precise value of a geolocation that's being provided along, or it will just know that geolocation of a certain type might be provided?
Yeah, sorry, thank you. My thinking is that the client does not necessarily know the precise value. It will just know that the value is being communicated faithfully by the proxy. Like it would do the right geomapping or whatever. It would compute the right token. It would send the right bit, but the client is explicitly made aware of it.
Yeah, I do wonder whether some of these examples can be made to work. I mean, geolocation is pretty dangerous to do these sorts of things with. So
yeah, I think there's a lot of sharp edges within that. Any more metadata you're adding. That's why, like with the 96 PR in particular, I tried to punt anything more than a single bit to a separate discussion down the road, and because to your point, any more information you're adding is it's a slippery slope, so to speak. Okay, thank you.
And tell me.
All right, hello. So I agree with Ecker that it's difficult or impossible to try to make this normative. Maybe one thing we could do is to have a normative statement about future standardization of protocols between a proxy and a target, of saying like, we really shouldn't approve things that give away, lots of information, but otherwise we can't really enforce this. And to echo what people have been saying, I think this really comes down to how much the client trusts the proxy. And the implicit thing whenever we're using an oblivious proxy is that trust relationship. And so anytime we try to talk about untrusted proxies or proxies doing things that the client doesn't want, we're kind of missing the entire deployment model. And I think even for the shadow banning case, like I could, as a client, once I learn that a proxy does shadow banning bits, I could choose not to use it and say, I don't trust you anymore because I don't want that in my contract. So I don't know if the shadow banning is really unique or if it's just one more thing the client could decide not to trust you about.
Yeah, I think the general shape of the things that Chris has described is what we're aiming for. I'm not sure that we're there yet on the pull request, but this is good input. Siobhan.
Yeah, I think I kind of mentioned something similar on the pull request, but yeah, I kind of agree. I think that, but I think that we should just keep it to be a should, and you can describe the many ways in which this can go really badly, and like why a proxy shouldn't just add, everything under the sun when it communicates with the server. But I think applications will have things that they want to do. So I don't know if there's much point being like, this is the exact amount of information that should be given out. David.
David Skenazy, privacy proxy enthusiast. Hey, Martin. I want to really echo what folks before have been saying. Like, this must is completely unenforceable, and we will probably have uses for this later, which all we'll have to do is, by the way, that must, just ignore it in that previous document. So having some text about, well, don't put the name of the user in there sounds with a should sounds good, and some like implementation guidance as we have more implementations is good, but I would prefer no musts for this.
I'm suggesting that at this point, perhaps it's time to go back to the separate work on the pull request, and maybe we can try to like get back on that, and like rather than try to like, I think I'm generally obviously what I'm generally hearing, of course, is people agree with me, but what I think the agreement is like that we should try to talk about the space here and like give some guidance, but not actually tell people not to do anything, and then we can work out the exact wordsmithing on that later offline. And this is also my issue 100. So I think this is clearly like a hot issue in this document.
Yeah, this is one of the more difficult ones. We will take this to the pull request. I have probably one final point here, and that is that some of the things that people are requesting here are probably generic HTTP features that don't exist currently, and they might be something that we would benefit from standardization with. And so if we took those things to, say, the HTTP working group, we could define new header fields for, say, the shadow ban bit, or no, I'm not going to say that we're going to do the geolocation thing, but other things along those lines. Okay, so I'm going to move to the next one. This one's a little more technically complicated. So I think a number of people have pointed out that this isn't particularly good at carrying all of the different HTTP semantics at the moment. We sort of have an atomic request and an atomic response. And if we want to do things like have large request bodies or large response bodies that stream and are processed in a streaming fashion, it's not very well set up for doing that. In fact, it would be a very bad idea to use the current thing for doing very large requests that are processed incrementally. And it also means that we can't do things like encapsulate 1xx responses. Let's take this out of queue, which is a little bit awkward. So I have a slide. Ben, if you have a question, I might answer it as we're coming up. So jump in if I'm... So this is just a sketch of a design. I'm part the way through writing this up. It turns out that writing this up is awkward and time consuming. So the couple of hours I've had to spend on this has not been enough to do it cleanly. But the basic idea is that rather than having a single AEAD invocation, either via HPKE or just directly itself, we invoke it multiple times and send the message in chunks. So this is easy for HPKE because it maintains its internal counter. For the AEAD, we need to maintain a counter and a nonce. And we can follow the pattern that we have in TLS for that sort of thing. For each chunk, we can prefix each of them with a length, which if we use, say, for instance, the quick variant encoding, it might cost 1 extra byte if you send a single chunk. And then the only other consideration here is that we need something to seal off the end of the message. So when you have a series of chunks, you need to know that the chunk that you're processing is the very last one. Otherwise, you're exposed to potential truncation attacks. So use something to distinguish the last chunk. There's any number of things that you can use. The simplest thing in many respects is just use a 0 length for the last one, because then you have a distinguishing thing, and you ensure that it's and you rely on the outer encapsulation to manage the length of the remaining things. Richard's going to complain about that probably. And that's all I have. So comments, folks.
Hi, Ben Schwartz. I first wanted to ask, can you just confirm that I understand correctly that the proxy already can stream requests and responses?
Yes, the proxy can stream everything it receives. It's the client and the server on either end of the HPK thing. Yep.
Okay. Yeah, so that doesn't seem as important to me. I understand the interest here, but I would ideally prefer for this to go in a separate document, possibly as an extension to HPKE, or as essentially an addendum to HPKE, because this is a very general purpose thing that you're describing here. It has really very little to do with HTTP. It seems like an expansion of HPKE itself.
Oh, I'd love to hear what Richard has to say about that.
So HPKE has a notion of doing a single key exchange that you then use for multiple EADs. Now it's up to the application of HPKE to like provide the sequence numbers to make sure that you process them in the right order, etc. But that's there. We could use that. It'd be pretty straightforward. What I was wondering is whether we need to invent something new to signal end of stream here, or whether like we could lean on the HTTP chunked content encoding or something like that too, which if I recall correctly has end of stream signal. And so you would just basically just have the encrypted thing be, here's some chunks and and you can decrypt them, and then the interior thing would signal when you get the last chunk.
I don't think we can rely on chunked encoding for this. I don't think coupling the chunk boundaries that you use for the AEAD with either the chunked encoding thing or HTTP2 data frames is a good idea. I think there's any number of reasons why you might want to be doing things like rechunking at intermediaries, for instance. So I don't think that's going to work particularly well.
Okay.
This design that I have here is... Go on.
Yeah, so what I was going to say is, like, if you're going to do the HPKE multiple EAD thing, you're going to need a little bit of framing anyway, so you might as well just put a bit there.
That's exactly what I'm suggesting might happen here. Yep. Tommy.
So one question, because I was waiting to see kind of the proposal, and I understand that that's not ready yet. Does supporting this streaming chain, does that change the wire format for the encapsulated request for requests that don't want chunked or streaming?
Yeah, the way that I've got it at the moment, there's a single 0 byte at the start of the message, but otherwise it's exactly the same. So exactly the same code that you have today, you put a 0 byte in. And if you're unwilling to support chunking on receipt, then you just simply read a 0 byte off and then run exact same code that you have today.
Right. So, okay. And that makes sense. I don't love it. So I guess the other question is, like, what are the use cases for Oblivious HTTP that currently would use this? Like, who is going to benefit from this byte and the potential complexity of implementing? Like, is anyone going to actually use this and test it out and exercise this as we're developing the protocol? Because I have a couple use cases that I'm currently using this for, and they're not needing this.
Right. So there's a lot of use cases that we have that are very small requests, very small responses, and that would be this would be a waste on those things. The question is whether there's anything that you might use this for that has much larger requests or responses. There are some of the things that I've been looking at for the NPC related submission of advertising related things, for instance, that might use larger payloads. It's uncertain.
and sufficiently large so that they couldn't just couldn't just essentially stream it to the proxy and then have that be one large request that's forwarded?
Well, it's more about being able to stream it into the encryption or decryption.
Okay.
Yep.
David Skenazy, this time mask enthusiast. So similar to Tommy, I'm not entirely sure we need this because, like, in my view, most of the use cases are for like short things. And like, if you're starting to get into things that are much longer, I mean, I know I'm the mask guy, but at some point you can use mask. Like if you really want to stream, we have another protocol for that might be a better fit. So at first I was like, oh yeah, this makes sense. But now that I'm seeing crypto foot guns, I'm kind of concerned that solving those might delay the rest of this effort. And unless we have a real use case that's not solved, I'd like to understand more why that one can't be solved by something like mask.
Right, so I suspect that the right thing to do here would be to put out a pull request, see what people think about the concrete implementation of it. I suspect that the feedback that I've gotten here will remain unchanged, but since I'm 90% of the way through the work, I'll probably go ahead and ship a PR, circulate on list, and see what comes out of that.
Ben Schwartz, just one quick note. You could consider separating this by MIME type, effectively. And that would allow
that would make an extension.
Yeah.
Yep. So in effect, that would mean using an extension, which isn't completely unreasonable. Number of ways to cut this one. Okay, so this is one of the more interesting technical problems that exists here. I think it might have been David Benjamin who first sort of reminded us that anti-replay is kind of a thing when you're doing this. When you seal something up in HPKE, there's nothing in it that ensures that the connection is live, and so a malicious proxy that gets their hands on a request can replay that request any number of times. And the server that has no defenses against these sorts of things might just process the request multiple times. So what we have at the moment, and this is going to require a little bit of coordination perhaps to address, is we've got some text in the draft that looks at the general problem and surveys the space. And there's a call out to a new draft that I've proposed to the HTTP API working group that talks about how you put timestamps in requests and how you deal with the problems in there. I will go on to the next slide to show you the sort of problem. So if you're doing anti-replay, there's sort of two broad ways that you can deal with it. First is you can just not care. This is often the case for things like DNS, even though perhaps maybe they should care in certain circumstances. A lot of DNS servers won't care about replays. And the other one is you take all the requests you receive and you remember them. And if you see a request that's played out twice, you reject the second one or all subsequent ones. For something like OHTTP, you just look at a slice of the request. The encapsulated key is a good thing to use in that case. You don't need to remember the entire request in order to recognize that something's come in again. You just need enough of that enc value to ensure that it's unique. Probably 16 bytes would do. So the problem with this is that you, even with as little as 16 bytes per request that you've processed, that's an infinite amount of state if you're a long-running server. So a practice that we've used in a number of other settings is to include some sort of timestamp in the request, and the HTTP date header field is not a bad choice for this one, even though the date is not used particularly often. And then you only need to remember requests over a short span of time. Anything outside of that span is rejected because it's too old, it's probably a replay, or too far into the future. Someone's got a wacky clock. For those requests that you remember, as they get too old, you just stop remembering them. It sort of keeps the amount of state that you maintain finite. That leads to the next problem, which is that client clocks are bad, and in some cases really, really bad. There's a paper that we cite that talks about just how bad it is, but it's not unusual to find clocks that are years bad. Some of them like centuries into the future, that sort of thing. Completely weird stuff. So the solution there, I think, is to just let the client retry. So you have the server send a signal saying that your clock is wacky, and the server response will include a date header field conveniently, and the client can just retry using the date that the server has provided. You just turn the value around in most cases. There's a number of ways in which this can go really, really badly wrong. You don't want to use the server's date for things other than an immediate retry, but you can use it for this one retry. So there's a bunch of stuff in the date request draft that covers the security risks of taking random clocks from random servers. But in general, this works reasonably well. It provides linkability between the original attempt and the retry. But if the retry is essentially the same request tried again, then it's not particularly bad. And yeah, there's Acme nonces as well in the chat. I don't think that allows you to do the time windowing thing, although it may be possible in that case because the server is the one that's generating the nonces.
It's similar to the server-generated date here, because the server can put the date nonce.
Yep. So it's essentially a token. So this is more or less for your information. I think this is probably a reasonable thing here. I think the challenge here is that we're citing a draft that's an individual draft in another working group. So I just wanted to make people aware of that possibility. We could probably break that dependency by folding some of the content in, but we haven't yet had the conversation in HTTP API about what to do with that draft. So there's a little uncertainty there. Thankfully, we have some other problems to solve, so this doesn't become urgent. Any input on this one? Okay.
So first, let me just state what I think is the case, which is that this is about replay by the proxy, correct?
The proxy is pretty much the only one that ever gets to see these messages. So yeah.
Right. Okay. Good. Just making sure I'm on the same page as you. I think. I mean, I guess I wonder. I know. As you say, clocks are terrible. But I wonder if the answer is just don't do that. We're talking a new protocol definition, and I wonder if maybe the answer is just say, well, have an accurate clock or it's not gonna work. I guess I'm just I know we talked about. You alluded to some of these things, but it's just naively accepting whatever date the server gives you has all kinds of other problems. I think. Well, I guess there are two flavors of this, right? One is where you naively accept it, but only for the purpose of this message. At which point you might as well just use knots because it's basically knots. Or the other is where you persist it. At which point now you have a tracking problem. And I'm not sure how to deal with it. And so it seems like maybe the answer is just it's just fix your clock. So I don't know, but I think I guess if I'm I think my bottom line is either we should do not try to correct the clock at all and just do as you have in this thing, or send a correct clock, or you're going to have to absorb a round trip for knots. I think is probably my take on this. I don't think trying to correct the clock is going to like this. Is that great an idea?
So you're thinking of having the server respond with a nonce, and then you have to make another request with that nonce.
Well, that's what you have to. The mechanics and the mechanics obviously are, if your clock is wrong, then you're going to send a request, and either it's going to be dropped or they're going to tell you to try again with some other new information. And the version the version you have here, the version you have in the next slide, effectively is try again with the correct clock. But I'm just saying that unless that if you're not going to store that clock information for very long, then you might as well just try with the nonce, and we can skip the clock part. And then the way to think about this is the clock is a shortcut around the nonce, right? Is one way to think about this. Anyway,
Yeah,
I'm not sure, but I guess I'm just trying to avoid having to define the privacy rules around precision of clock.
Yeah, I mean, I went through it in the other draft. I think it's probably tractable, but yeah, you essentially, if you have a bad clock, you end up with a round trip, an extra round trip for every request that you send, which is unpleasant. Ben.
So I looked just briefly at the, I guess, two drafts involved here. Neither of them seems to mention the problem of distinctive skew linkability. So if you're the only client who's 11 seconds behind, then all of your requests become linkable. You lose the oblivious property. So including a date header in the inner request is a little scary, unless it's, I guess, probably fuzzed rather than quantized. Anyway, something to think about.
Yeah, I did talk about fuzzing, but I should probably have brought that out a little bit more. Maybe Eka's idea is much better. Tell me.
One high-level comment on this is, like, I would suggest that the normative bits should be a bit more generalized, that they should be around the fact that the client and the target should ensure that the protocol that is encapsulated isn't going to be vulnerable to replay attacks. And then drill down more specifically for the binary HTTP case and say, okay, here's the date fielder. We talk about the technique. And then, yeah, I mean, calling out to your draft makes sense, but I think it could probably be a pretty soft reference, because other protocols, like if I'm doing just DNS message raw in here or something new in the future, like that will have their own considerations, and those don't need to be a fundamental dependency from the main OHTTP draft.
Yeah, that's this is really only HTTP at this point, so I don't think we need to make it particularly generic. But it does. I think we do have text on the generic protections that are necessary. If we don't, then let me know. We'll fix it up. Eric.
Yeah, similar to Tommy's comment a moment ago, I think this is enough of a case that a lot of the uses of Oblivious won't care about this, to the point where I don't know if this really belongs in the main Oblivious draft at all. I think this should either be something generalized, or maybe just a quick informational draft of, if you care about replayability attacks and your Oblivious usage, here's what you do about it. And then the main draft can just be nothing other than a citation of, hey, replay is a concern for it. Here's the draft to look at if you do care. But overall, since I think the majority of usage won't care, I don't think this should be polluting the main draft.
Okay, let's take this to the list, because I think this is a little bit more challenging than I had anticipated. Let's see where we're up to. And the queue is drained. Great. So we'll take that to list. There's some ideas floating around here that we can probably take up. I'm not convinced that we can ship something like this without some replay protection, but we'll see. So final issues, a couple of small things. Issue number 58 and 19 are things that I think we can dispense with relatively quickly here. I just wanted to test sense of the room on two of these things. The first one, 58, asks whether this work should be experimental. I'm going to suggest no. Does anyone disagree with me?
Please come to the mic if you have an opinion on this, whether this document should be experimental or standards track.
I've implemented this. I think we plan to ship this. And there are others. So it doesn't seem to make much sense to make it a grand experiment. But I'd like to hear reasons why.
There's feedback on in the chat that says not experimental.
Wouldn't it be great if MeetEcho would scroll the chat? All right, so issue 19 is talking about discovery, and there's a number of things that we could talk about in discovery. I think I'd just like to reaffirm that we're not going to do it in this draft. We may do it in this working group. I think Tommy has a document that's talking about discovery, or at least some aspects of the discovery related to this. There may be other things that we need to discuss about discovery. I suspect this is a very long topic, and we should continue having those discussions. Does anyone think that we need to address more of the discovery problem in this document? Yeah, I've got a couple of notes, but those people are sensible. Because I don't know how to do discovery in this document. Because, yeah, I can imagine the service B config stuff is going to be enough of a challenge for the, what is it, DDR. So.
Yeah, I would note that the charter text on this says that the working group may work on other use cases or deployment models, including those that involve discovery. So this is at best secondary in the charter.
Right. So with that feedback, I think we're good to close that issue off and move on. That's me done.
Thanks, Martin. I think next is Thiru.
Hello.
Hello. Thiru, did you want to ask for slide?
Yeah.
Did you want to share screen, or I think it might be easier to do sharing of preloaded slides?
Yeah, that would be great. Yeah.
Wait, do I have to do that? Okay. Let me see. And then give this to you. Okay, can you try controlling that?
Yeah. Yeah. Hey, good afternoon, everyone. I'm Thiru from Akamai. I will be presenting the Oblivious proxy feedback draft. We published this draft a few weeks back, and we got some feedback on this draft, so we worked on that. So I'll share the feedback as well as what this draft is trying to propose. The problem is quite straightforward that because there's an Oblivious proxy, which is basically masking all the clients behind it and sending the traffic. There's a good chance that the traffic that's coming from the proxy could exceed the capabilities of the target server, and that would cause it to start rate limiting the traffic from the proxy. This is something that we have seen in various deployments today with regard to various types of rate limiting that gets applied. But this is quite different that because there's a proxy involved, typically the rate limiting is usually applied for clients, but in this case, the rate limiting would get applied to the proxy. And if the rate limiting gets applied to the proxy, then it would start harming all the clients that are behind the proxy. That's the problem that we are trying to solve by this draft. The proposal is to signal the overload from the server to the oblivious proxy, and the proxy uses this feedback to rate limit any HTTP requests from like offending clients or misbehaving clients or botnets which are trying to overwhelm the server. One of the feedback that we got was there's already a draft in HTTP API working group with regard to use of rate limit headers, which basically is publishing the quotas or service limits to clients. We updated the proposal that we have to align with this draft to basically send those quotas or service limits only to the proxy and not to these offending clients. So what we did was we introduced a new proxy header. Earlier in the 0.0 version, we had just a feedback header, and the feedback was not to pick a very generic header. So we changed it to OHI proxy feedback header, which provides feedback from either the request resource or target resource to the proxy. And the whole idea is the proxy would remove the header before sending the HTTP response to the client. A simple workflow would be like the client sends in, that's an crafted packet just to target the server, and the target resource identifies that it's an malicious request, and it sends in 400 response along with the OHI proxy feedback back to the request resource, which again forwards it to the proxy. Proxy basically takes it out from the 400 response, puts it in the request resource takes it out and puts it in the 200 response only for the consumption of the proxy, and sends the encapsulated 400 response without this feedback header. And then the proxy applies this rate limiting rules that if it believes is the right limiting rules that the target resource has given it, and the 400 response would hit the client back. So what we did was all these parameters that we have would be part of this proxy feedback header. So we have picked the various fields that are there in the rate limit headers to be part of this header, which would be sent back to the proxy for enforcing these rate limits, either for the proxy to enforce rate limits, or for if it's an offending client which is trying to attack the server, then the target server can ask to the proxy to rate limit this offending client, and the server obviously in this case would not have any information about the client.
Hi, could I ask you a clarifying question, please? Sorry to interrupt.
Yeah.
Could you go
Yeah,
back
go ahead.
one slide to slide 5, please?
Sure.
So when you were first explaining this, I was assuming that the request resource was getting too many requests from the proxy resource. But now I'm kind of thinking that the target resource is getting too many from the request resource. So can you clarify in which server is being overwhelmed or receiving malicious requests here?
So in this example, we have just targeted the target resource getting an offending packet, for example, assuming it's getting an abnormal header. The attack could be even on the request resource that it's getting, let's say, a garbled encapsulated request, and it tries to decrypt it and it just fails. So the attack could happen. The draft currently talks about attacks, encapsulated malformed request or higher rate of requests coming and hitting the request resource, or it could be hitting the target resource with crafted packets.
Okay, thank you. I'm going to need to think about this some more.
Thank you.
Hi, Eric Scola. I guess I'm a little unclear on how this is supposed to work. So, you know, you give the example of an undecryptable message, but like it's perfectly easy to make a decryptable message, right? So I guess like,
yeah.
So I guess like what I'm trying to understand, I mean, it's like there's like one very specific set of edge cases where somehow there's a particular kind of like message I send that like has abusively high single message consumption of resources on the server. Like I do something that requires you to like make like enormously powerful big computation, right? And that no legitimate client would ask for. But the way that DOS attacks like frequently work is I send legitimate appearing requests, and they're indistinguishable from illegitimate requests, and their problem is the volume of those requests. And so I don't understand like if you're able to handle 1,000 requests a second and you're getting 5,000 requests a second, like to which ones do you send the throttling messages?
Yeah, there are two types of attacks when I was referring to. Either it could be a simple HTTP flood, or it could be a flash crowd scenario, and it's quite undistinguishable, in which case the target resource is getting overwhelmed and it want to handle those. The other one is basically an attack where it could be a slow loris, or it could be a malformed request, or a garbled request kind of an attack.
Okay, but we agree this does not work for the ones where it's just a lot of legitimate looking traffic, right?
Sorry, I didn't get that.
We agree this does not work for ones where the traffic is legitimate looking, right?
Yeah, yeah. The
Okay.
malicious request is not for the legitimate looking, but for if the target resource is getting really overwhelmed with, let's say, millions of requests coming from the proxy and it wants to rate limit, then it can basically signal that the rate limit is not just specific for a client, it could be for the proxy as well.
Okay, but I guess I'm still not like, I hear what you're saying, but I don't see how this works, because you're just rate limiting everybody. Like you got I mean, for this to work properly, you have to discriminate between the valid traffic and the invalid traffic. And you know, if you just don't like how much bandwidth you're getting, like slow down your TCP stack or something. I mean, like, it just seems like, you know, I mean, I guess it seems like, I guess if you're just trying to like narrow the amount of bandwidth that's being consumed, but you're not like actually providing any better service, right?
Yeah, narrowing the bandwidth to basically give an equal share to all the clients, both the legitimate and
but no, but I don't understand how that works. What I'm saying is that like the nature of the proxy is to transparently send the data coming in and the data coming out. And so in order to, and so like, and it will like naturally attempt to share between those clients, right? And so if you want it to like do less, you've got to somehow tell it, give these clients less and these other clients more. And I don't understand how you're saying that.
Well, but Ecker, the whole concept here is that the resource server can't, or the request server can't distinguish the clients.
That's my point.
I think the idea here is to say, dear proxy server, figure it out, because you can see the clients.
But okay, but I guess like, sure, okay, I guess, but like, I mean, I would hope the proxy server would always do that, I guess.
One might think. But, okay. So we have a bit of a queue here. Tommy?
Hey.
All right. Thank you, Tiru. So actually, to this point that you have on the slide right here about aligning with the rate limiting, it doesn't really seem to be quite aligned. I see that you're using some of the same terms as like the values of your HTTP fields, but in the rate limit document, those are the actual field names, the header names. So I would really suggest like just use the rate limit headers. I don't see really what we're getting from these additional ones. And overall,
yeah, Tommy, the reason why we didn't pick the fields as what is there in the rate limit header was we didn't want this signal to go back to the client. If it goes back to the client, then probably the client would know that, hey, its attack strategy is being identified and it's being mitigated. So we wanted the signal only to reach the proxy. So how do you distinguish the rate limit fields that are?
I guess I would say overall for OHTTP, if it's not already said, the proxy should not just be relaying arbitrary headers between the target and the client, or the client and the target. If that's not said, it should be said, but I wouldn't expect that the proxy would just say, oh yeah, the target can just include whatever random data it wants, and then we'll send it kind of as clear text, not inside the actual encrypted payload.
Right. And with the current rate limit header, I believe it will be in the encapsulated response. So the proxy wouldn't even know what is there in that, right?
Yeah. And then overall, this seems like it's like what we should have here is just normal rate limiting between the target and the proxy, saying, hey, proxy, you're sending me too much. And then the proxy should just figure out on its own what it needs to do about that. And it can identify its own clients that are overwhelming it.
Right.
But that's it. We should just leave it very, very simple. This is just 2 layers of normal rate limit headers, and we don't need another header field here, I think.
Okay, so sure. We can restrict that.
Just quick point of order. Tira, did you have more presentation content you wanted to get through? Because we have a queue here, but we could put that off so you're done.
Sure. Just one more slide. So basically, if I wanted to have a discussion whether this header needs to be only conveyed to trusted proxies, and if an attacking proxy which is colluding with attacking clients would leak this feedback to change the attack strategy. So is this something that needs to be only conveyed to proxies which authenticate back to the target and resource servers, or could this be used with any proxy? That was one of the questions I wanted to discuss with the working group.
All right, going back to the queue, Eric. Mr. Escorla.
Didn't empty myself the queue.
All right, Rajiv.
GVA from Piconets. Just wanted to say, I have only cursorily reviewed the draft, but at least based on Thiru's description, if we can go back a couple of slides, I'm still unconvinced whether this rate limit based approach is the right approach to take to try and mitigate these challenges. So I see clearly that there are two types of challenges here that, like Eric mentioned. One type, which is where there is a obviously individual request that is likely to be malicious in nature, either because of the scope of that individual request or how it is structured. It may contain junk, or it may contain the kind of content which is designed to overload the server. Okay, so there the challenge is the fact that it's a malicious or overloading style request which you want to restrict. The second condition that we are looking at is, like Eric mentioned, a large amount of legitimate looking requests, but just at a scale designed to disrupt the target server. Okay, now in scenario one, where it's an individual request that is malicious by nature of its content, okay, will rate limiting even be an appropriate response for that? Because are you going to send back a rate limit of 0? Because that's the only way you can guarantee that the next request does not come through, right? Because here it's not the volume of the requests that is a problem for the server, it's the nature of the request. So I have 3 clients, each sending 1 request per minute, but if those requests are designed to bring my server down, and the only way for me to stop them from coming is to send a rate limit of 0, because these kind of malicious requests are not designed to be limited by a rate limit type of mechanism. So in the first case, rate limit is obviously the wrong approach to take to try and mitigate or block that particular traffic.
Hey Rajiv, I'll answer the first question. I think if you look at the rate limit headers draft, right, it allows a rate limit option where you set it to 0. Basically, that means to say that the server is not willing to accept any further clients. So the rate limit is typically a block action.
Correct. But then in this particular scenario, because of the fact that you have 2 levels of intermediation with anonymization happening in between, what you have effectively done by allowing rate limit 0 to be set is you have DOSed your entire proxy infrastructure.
No, so if you see the headers that we have defined multiple headers. One is rate limit p limit, which is for the proxy, and one is rate limit hyphen limit, which is for the client, basically.
Which then brings into the picture the fact that now the dependence is on the target server somehow knowing that this is coming through a proxy infrastructure, and I need to have separate headers for that. Or you're talking of putting intelligence at the requester resource level to identify that when I get a rate limit 0, okay, I am now supposed to be setting the rate limit p limit and sending that onwards to the proxy. But in most cases, the expectation from the target resource will be, hey, I am talking to the requester resource. That's all I know. Okay, the whole point of being oblivious is that the target resource should not have to know that it's coming through a proxy infrastructure. Anonymization, intermediation is all a black box to it. All it knows is I've received a a malicious request from request resource. So I'm sending a rate limit 0 to that request resource, which means any other traffic coming through that request resource has effectively now been DOS.
Yeah, it all depends on if the request resource and target resource, right? The request resource always can share that it's coming via a client or a proxy, right? Otherwise, if it's, let's say, if it's a direct communication,
So then
client is
that calls
attacking.
into question. Yeah, the one of the at least in the
for
draft,
example, in case the target server could be attacked by both the client directly talking to the server, or it could be coming via an oblivious path, right?
Yeah.
In
So
both the cases,
in
the
the
server
draft,
needs to have that context, right? If you see what we have proposed is there has to be some communication that's happening between the request resource and the target to identify whether this request actually originated because it was oblivious or a direct communication. So that way, oblivious basically, so that the target can actually set the right kind of headers there.
yeah. So this kind of goes against the text, at least in the first section of the draft, where it clearly says that the whole purpose of oblivious, one of the use cases that should be supported is the fact that traffic is coming through an oblivious proxy channel is masked and not visible to the target resource. The target resource should not know nor care that this is traffic coming in from an oblivious resource.
Yeah, it doesn't care about the client identity, right? I mean, that's the purpose of oblivious is my understanding, but whether it knows that it's coming because oblivious protocol is being used, it's not going to invade the client privacy in any way, right?
Okay, so on the one hand, then you're saying that yes, you will have some sort of probably header level communication between the requester and the target, saying that, hey, oh by the way, this isn't a request directly from me, it's for a downstream client of mine, but it's anonymized, so therefore I'm not sharing that with you. So and then you're talking of the target server then having intelligence in it to understand this communication from the requester and know that if I see a malicious request of type 1, I need to send back headers specifically allowing the requester resource to continue to come to me, but also to communicate downstream to its client saying that you specific client are no longer allowed to come to me.
Right.
Okay.
I think we should move on.
Yeah. Go ahead, Siobhan.
Yeah. I think we should
come back
take this onto the list, maybe.
Yeah, Raju, let's take the discussion on the list. But good questions. Thanks for all the questions. Yeah.
Can I very quickly address my second point, which is the actual volumetric attack that rate limit was designed to counter against? I try to keep it down to 30 seconds. So again, in a case of a rate limit, the same limitation applies. The target resource has to be aware that this is volumetric traffic coming through a proxy infrastructure of some kind, so that you do not land up in a scenario where the rate limit basically DOSes your proxy infrastructure itself.
Correct.
And secondly, there's an even bigger problem if you come back to the previous side. On the proxy resource side, when you're dealing with a volumetric proxy, the minute you start having to maintain state of saying, okay, these are the list of clients who are blocked, or these are the list of clients for whom these rate limits are set, especially in a volumetric attack, that effectively becomes a loss on your proxy resource, because your state table is going to grow to a point where it probably is going to land up becoming unmanageable. Right. So that's also something.
Yeah, it all depends in the way that it all depends on the way that you enforce these rate limits. If the proxy is authenticating the client, then it's a different way of enforcement. If it is not authenticating, then how do you put ACLs? For example, we have been implementing rate limits for DDoS attacks all the while, and we could even program millions of such IP addresses to be blocked or rate limited. So I can share more details on how it could be done.
Okay. So but I just point out that should be something that should be addressed in the draft specifically, because it is a non-trivial problem. I'm pretty sure you agree with that. You have a lot of years of engineering behind being able to do what you're saying you're doing now, right?
Yeah. Thanks, Rajiv. Let's move on. Eric Orth.
Yeah, sort of quick mental exercise to sort of decide if this is a worthy thing to pursue or not. If we ignore your specific proposal and just focus on what's the simplest thing to solve the issue, I limit the issue down to saying this specific thing that this request was doing, something's bad in it, and the proxy needs to know that to either ban or limit or act on that specific client if they have more requests of that sort. I think the simplest thing we can do is the server sends a bit to the proxy saying something was bad about this request. And then that's one bit going from the server proxy, and this immediately sounds, hey, this sounds very, 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 very similar to that whole shadow banning conversation we just had 45 minutes or so ago now. So from that perspective, maybe we should essentially shelve this until the debate is settled on the proxy banning thing. And if it's decided that, yes, sending one bit or similar information from the proxy to the server makes sense, okay, then we should go back. Okay, does it make sense to send similar information from the server to the proxy? Because that's, in my opinion, exactly what this is. And if it is, then we can discuss, okay, what's the exact stuff that makes sense to be able to send and pick this back up again.
Okay.
Hi, Ben Schwartz. So I think this issue is real. I think it's worth solving. I think that I understand the concern that you raised about using the unmodified rate limit headers directly. And I think the solution is to use the unmodified rate limit headers and work with that draft and the OHTTP draft to make sure that they actually work in the way that you want it to work here. So I don't think we need a new.
Ben, I already reached out to the authors of that draft to help us out. So yeah, we'll work with them.
So yeah, I don't think we need a new header here, but I do think there's some work to be done.
Yeah, the whole challenge was how do you make sure that the proxy strips it off? So if there is a way we can, the target resource can put these headers, but how does it from the HTTP response, and how does it get percolated back in a way that it's not being sent to the client? We can discuss that and figure that out.
Yeah, that can be specified either as an aspect of the header itself or as an aspect of OHTTP proxies.
So Eric Nygren had a fairly good statement that I think probably works in this case. It requires communication between the request resource and the proxy, not the target resource, and I'll get to that. But just like in the issue 66 discussion, we were talking about sending a single bit that says this client is suspicious in the direction of the proxy to the request resource, not the target resource, the request resource, so that the request resource can act accordingly. The same applies in the direction from the request resource back to the proxy, and that single bit with the same sort of standing would work. It does require there is a private communication that the proxy resource understands this message, or that the proxy resource is not generic and doesn't blindly pass header fields along. But I think both of those things are quite reasonable in this setting. For the target resource communicating this state, there's a lot of cases where you'll have the request resource and the target resource co-located, in which case none of this coordination problem really needs to occur over the wire. In the other case, I think that the rate limit stuff doesn't work in this case because of the way that it depends on understanding who the client is. But there may be some ways in which we can signal those sorts of things. I think there are two different solutions there, though, and I think the more important is the signal that is private between the request resource and the proxy resource.
Okay.
And it is just that one bit. This request was potentially suspicious, and then you potentially have to have the volumetric things as well.
Sure.
It's interesting.
So Martin, you're suggesting that for malicious requests, we just say that it's a malicious one rather than providing any rate limit parameters, but for proxy, continue to have the rate limit parameters being pushed on to the proxy.
Yeah, I think that in a lot of cases, though, as Eka pointed out, the individual request won't be problematic. It will,
Okay.
you will need some other channel, or perhaps a separate type of signal that says, hey, by the way, the number of requests or the rate of requests that I'm receiving is too high. Proxies start looking for individual clients that are acting badly and try to eliminate or slow them down in some way. That, I think, requires probably a richer out-of-band communication than what the individual request headers can provide us with.
Okay. Why do you think that the inline one is bad and we need an out-of-band new communication channel?
Sorry, I'm going off mute, and then you asked me a question. For exactly the reason Eka stated, which is that individual requests in a denial of service state will generally be genuine or appear to be genuine. So
Okay.
it will be from the perspective of the server that's operating here, it will be unable to distinguish between the requests that are coming from bad actors and good actors. And all it needs to do is try to push further out toward the edge the responsibility for filtering those down.
Got it.
One additional point that just came, into mind, by the way, Rajiv here, was the fact that in cases of most target resource servers, while they may implement things like sending out rate limit headers and stuff like that, many times when there is detection of any sort of malicious traffic, there may also be other security measures that kick in, like an application level firewall that starts blacklisting stuff like that. So having some text in the draft specifically saying that, hey, any traffic that's going towards a target resource from a request resource must contain some header or some indication that it's coming from a proxy, which then allows the target resource to say, hey, yes, I'm seeing a malicious request that would, under normal conditions, lead to an immediate ban on that IP. But because it's coming from a proxy infrastructure of some kind, I don't do that ban right now because I may end up impacting legitimate users. Which again, kind of, to me, it's a bit of a disconnect between the text of what the draft is intending, saying that you don't want a mechanism where target resources have to be necessarily aware of the oblivious framework in order to be able to support the traffic. So I just thought this is also something, since we're discussing security implications, that should be part of the draft, and it's a problem that needs to be addressed. Even if we don't have a solution for it, at least say that, hey, this is a potential problem that we need to look at.
Yeah, that's a good point, Rajiv. I think we can add some text to address that.
Okay, great. I think we've drained the queue. Yeah, so it seems like my sense is that there is a need for something like this, but maybe that should go in the HTTP API rate limiting draft in a section over there, or sounds like more fundamental work is needed in the current draft.
Yeah, so Shivam will work on the feedback, and I think we'll get a new version, and then we'll take the discussion on the mailing list to see which working group fits this.
Okay, perfect. Thanks a lot, Thiru.
Yeah.
Great. Tommy, you up next.
Thank you. Let me show the slides. And I'm going to forego sharing video for the moment. Apologies. All right, so we recently posted a draft about how to do some discovery of oblivious target configurations via DNS using service binding records. And this is what Martin was referring to earlier as one of the directions for discovery. This is certainly not the only mechanism that could be used for discovery. It is a particular model that works for particular deployment scenario. There are other aspects of discovery that we would want to get into, but this may be a good starting point to the conversation. So what does this document do? It's relatively simple. It sends the oblivious configurations as well as, when needed, the HTTP paths for targets, and it's specifically for the oblivious targets. And it sends these through DNS records. And these are defined using the service binding / HTTPS RR types, which allow definition of new parameters. And it explains how you can use these for discovering the configuration for a generic oblivious HTTP target, and essentially learning that a server that you would normally access not obliviously also does offer an oblivious target. But then it also talks about how to use this specifically in the DNS case for doing oblivious DNS over HTTPS. And this is the part where, at least from my end, we have a lot of experience deploying it now, and this is where this becomes interesting. This allows us to integrate with work that's going on in the ADD working group to discover encrypted resolvers, either via a DNS query to a well-known resolver.arpa name, or as something that can come in DHCP or RA messages. And this also explains the similar use for the previous version of Odo, which is the experimental version that was the precursor to a lot of the oblivious HTTP work. What this document does not do, at least in its current form, is talk about anything for oblivious proxy discovery. That's one thing that I think Martin brought up in an issue, and the draft could probably be more clear and emphasize this more strongly, that it does not cover this. The proxy discovery case could be added, but I believe it's something that's quite different. As we discussed earlier, the relationship between a client and a proxy and that trust about what it's doing, what it's potentially adding or not adding, really matters. And I don't see as much of a use case for that being arbitrarily discoverable in a mechanism like DNS. Maybe there could be a registry of known and trusted proxies, but what we're talking about here is discovering targets. There will be a little bit more on this later. So as an example, we have two cases here. We can have oblivious DNS being advertised for essentially the discovery of encrypted resolvers case, DDR. So we would have a record for dns.resolver.arpa. Amongst other things, it could say that it supports an Odo server. This would include within it the fact that this is an HTTP target. It would have the path to use for DO on this query, along with the list of OHTTP configs. This is quite similar to how the encrypted client hello TLS configs can be communicated in the same way. And you could imagine this then works also for a generic oblivious HTTP case where I could learn that metricsupload.example.net supports oblivious HTTP as a target, and I could learn what its config is there. So to walk through a very specific example, and this is kind of the real life case that we would have, I have a client that has an oblivious proxy that it goes through, that it trusts, that it has a strong relationship with, and it currently would be by default talking to one or more oblivious DNS targets that it knows about. This is how iCloud Private Relay works today. And in this scenario, I could imagine that I join a network and I connect to the ISP DNS resolver just for my normal maintenance traffic. I can query it for dns.resolver.arpa, and I learn that the ISP has designated a specific oblivious DNS target. And the reason that this could be interesting is maybe there is some in-country or in ISP policy about the type of responses I get from a server. There are various regulations in places about what content someone may be accessing, and so the case of maybe my ISP knows that this is a child's device and it wants to have some filtering for particular content. I do not want to, when I'm using this privacy system, disclose my kind of full browsing history to that ISP DNS infrastructure, but I would be happy to go through a proxy and use oblivious DNS if that is safe. And so if we learn that configuration, we can essentially bootstrap this. And the client is now able to access that ISP selected oblivious DO target if that target is known and trusted by the proxy. So there is a transitive trust relationship here in which the client has to trust the proxy, and the proxy or some other mechanism that the client can check against validates that this is not a unique per client target, but is something that is more widely known and registered. So to be very clear about the deployment model for which this works, this is a case where the client knows one or more proxies that it already trusts. It's not trying to discover that. The client wants to be able to access oblivious targets that are published by their local DNS or public DNS. The client needs a way to know that this target is supported by a proxy and what path to use, because oblivious HTTP does require that there's a mapping between the request to a proxy and what the target is. I'll point out, and there's actually an issue on the main OHTTP draft that Ecker raised about the flexibility of these mappings. While OHTTP does require that you have a one-to-one mapping, that one-to-one mapping could be something that is also expressed as a URI template. So it is possible to have this be a bit more generic as long as the proxy is doing the correct access control checking. I think that having an unknown or untrusted proxy that I need to discover, that's not a very clear use case from what I can see right now. If someone does have a use case for it, let's definitely talk about it. I'd love to hear it. But at this point, I'm not aware of that. So the question is, do we want to adopt something in this direction? Certainly, there could be more refinement and changes, but do we want to be able to communicate these types of configs in service binding records? If so, it seems like it should be in scope for the charter as one of these secondary items. And as part of that, we'd like to get these service binding parameters allocated because we are planning on using them for our oblivious DNS deployments. And that's all I have.
Hi, Tommy. Thanks for raising this. I'm a little, I understand what you're saying, and I think this is like a reasonable thing to think about. I'm trying to think through some of the privacy implications, and it's not like entirely clear to me that the privacy implications are as straightforward as one might imagine. And so let me give you a concrete example. Supposing I have two endpoints. I have two DNS endpoints, A and B, right? And they're otherwise identical. And I'm the ISP, right? And I have two DNS endpoints, A and B, and they're always identical. And so to everybody but you, I give A. And to you, I give B. And and that they're specified by path or whatever, right? And so now, so now the proxy like faithfully does this and hides everything, but it doesn't matter because I've now linked up the DNS publication in that. And so I'm worried. I'm just really worried that like actually this will be quite easy to attack. And I can imagine a bunch of other like variants of this where like I give like really short DHCP lifetimes, and then I encode your identity in single bits, or I have multiple things. I mean, like I can imagine a lot of ways to attack this directly. And so I guess like I want to persuade myself that this actually is going to work.
Right, exactly. And I think that's so the approach we are thinking of here is, again, relying on this relationship between the client and the proxy, and that there is trust there. The proxy is in a place where it can ensure that the volume of traffic of essentially different clients to a given target path, as well as like the key IDs of the configurations, is sufficiently large. The proxy can definitely recognize, or clients could all report to some other entity for transparency, what are the paths and stuff they're seeing, so you could detect, oh, this is a unique client and they're the only ones who get this. And that's part of why I think there is I think a case where this discovery makes sense and is useful, but it has a lot of constraints on it, and it doesn't make sense.
I mean, you're really dropping out a lot.
Oh, sorry. I don't know what to do about that.
You're better now.
Okay.
Sorry.
Anyway, I think it depends a lot on how the client can trust the proxy or work with other clients to detect unique configurations. And I think we have a call out to some of the work that Chris and MT were doing for key consistency.
Right. Well, I think, I guess so. So I think, well, I guess I perhaps feel differently about this in the sense that, like, I feel like we kind of like hand waved this away when we started Privacy Pass, and now we're like having to fight it because we hand waved it away and we don't have a solution. So I guess, like, I'm a little reluctant to take that bet again, without having like a more clearly worked example of how to actually make this work. But I agree it's a problem worth trying to solve.
Thank you.
Hey, Ben Schwartz. So maybe some people didn't see the comments on the OHAI mailing lists about this, but so I read through this and I conclude that this arrangement is, first of all, not secure. Like, above all, this arrangement essentially hands over root CA powers to the proxy server, who can now arbitrarily and invisibly impersonate any website on the internet. It doesn't even have to be a website that actually supports oblivious HTTP. So I am seriously concerned. I do not support the draft as written. I do think that
Okay.
there's...
I do disagree about that model. I think it'd be good to explore that a bit more.
Sure. So
I don't think there is a trust relationship between the client and the proxy already, and I don't think that it's going to be able to just tell the client whatever keys it wants. That's not where the keys are coming from.
Right. The keys are coming from over an insecure channel. They're coming through the DNS, which is assumed insecure unless stated otherwise. So in all our threat modeling for the web, we always assume that a DNS attacker could be swapping in arbitrary things. We don't trust, we don't rely on the IP addresses coming back from DNS or anything else to be secure in order to authenticate the domains that we're visiting. This would change that. This would say that if the proxy can poison a DNS cache, if the entity that operates the proxy can also execute a DNS cache poisoning attack, or just operates a DNS resolver, which seems entirely reasonable, or happens to be near the path between the user and an insecure DNS server, which also seems highly plausible for a lot of these proxy deployments, then the proxy can swap out or even inject a synthetic OHTTP config for whatever domain the user is attempting to resolve, and then act as the origin. So to me, that makes this really a serious problem. I also have some other concerns with the design. I think the use of a path here is basically wrong. The DO path parameter in the DO service B mapping is not a good thing. It's there as a compatibility hack to be able to work with pre-existing DNS over HTTPS servers. But the DNS service B mapping has a long, multiple paragraphs of caveats trying to explain the dangers that this creates, because that path, again, is attacker controlled. So so you can't assume anything about it. There's some problem, like multiple paths on the same server can interfere. So I think that we shouldn't have a path here, right? There should only be, that should somehow be a fixed value effectively, through the .well-known mechanism.
I mean, a path on the target is required to be known by the
right,
proxy.
I understand, but we don't need it to be flexible. Given that there is no install base that we're trying to maintain compatibility with, we can say in the case where you are trying to upgrade a standard HTTP connection, in the case where you're trying to bootstrap OHTTP off of a DNS name, where all you have is the DNS name, then we can say there's a fixed default path for that, or there's a fixed in-band mechanism for learning that path by, again, querying to something in .well-known. I do think that there's a version of this that can be made secure and workable, and it's actually much simpler. And that is to just set a flag here that says, I do OHTTP, or I require OHTTP, and then let the client actually contact that origin directly and, through an authenticated channel, learn the OHTTP config, learn the preferred path, and then use them.
All right, Ted.
Ted Hardy speaking. Can you go back to slides 7 and 8, please? Start on 7. So if I understand this correctly, once the client has gotten information that the ISP DNS resolver is accessible through the ISP DOH target, it tells this information, it starts to use this information through its proxy. And I want to make sure I understand this correctly, because is it your presumption here that if the ISP DNS resolver presents an ISP ODO target, it must always be accessible to all parts of the network in order to work with any proxy? Because typically ISP DNS resolvers aren't globally accessible, and this makes them so, and I want to make sure I understand that that's your presumption here.
That is correct. It doesn't necessarily need to be open to anybody in the world. It could certainly have an allow list of known proxy deployments that it is willing to work with. But yes, it does need to be reachable via the proxies, and that means it's not isolated within the ISP network.
Okay, so I think this is worth unpacking a little bit more as you think about how this goes, because there are a couple of consequences to that. One is if you say there's an allow list, you either can pay a penalty by checking each one of the proxies that you have access to find out if any of them are on the allow list. And that's perhaps not a very serious latency penalty, but it definitely would occur if the only way to discover whether it's on the allow list is by experimentation. Or you can publish the allow list in some way. And I think if you publish the allow list, you actually have changed the scope of what you were talking about from changing how do I find a target to also how do I find a proxy, because what you're in effect doing is using the information from the information carrying the target list to also carry the permitted proxy list. So I think if you're going to go down that path and use that allow list as something that's published, you're in effect, whether that's generic or not, you are providing discovery for proxies. I don't necessarily think that's a bad thing, as was pointed out on the list. This is sort of a twinned problem here. A proxy is useless without targets, and a target is useless without proxies. They don't, without knowing both of them, you actually can't get this oblivious service. But I think if you are going to do that, you have to kind of rethink architecturally that that's the scope now, and is this the best way to do it? And maybe that does need some more thought. Thanks.
Right. Thank you. And just to respond quickly to that. So yes, you certainly could have an approach where along with the target information and target configuration, you get a list of associated or trusted proxies. The other way that this can work is, again, the client has to know with its proxy what the mapping is of paths. So if the client does have multiple proxies, it essentially needs to be able to ask its proxy, have you heard of this target? Do you know how to access it? And so it's not like we will actually have to create and just try random requests. It can have its own communication with proxies to say, do you already have an established relationship with this target?
So I agree with that. Thank you. And there are other ways you could do it as well, right? The DNS resolvers target could tell you what its reachability limits are, and say basically give you a reachability limit that's only within the ISP or only within some region, et cetera. And so you could do it in a bunch of different ways, but I think it may be important that you work out in a little bit more detail which one you expect to be the standard.
David Skenazy. Hey, Tommy. So overall, I think there's definitely value in having a way to, for a target to be able to say, hey, if you want to talk to me, here's a way of doing it that improves your privacy. So I like that. I think there's a problem worth solving here. However, and I think, some of the deployment concerns are somewhat orthogonal, some of them, not all of them. But the point that Ben made where because of the way we have Oblivious HTTP today, you don't have a step where you verify ownership of the private key for the TLS certificate. That breaks kind of the security model of a lot of things. So I would say totally agree with the problem to be solved here. I think we should refine the solution to make sure that that gap is fixed, because otherwise this sounds like a giant foot gun. Thanks.
All right, thank you. Martin?
You in front of me, I wasn't sure if it was me. So I'm sort of wondering whether there is something here that's a little different in terms of the design that might be able to work. So I think the large open problem that you have here is that there's a target, and you've described a way of discovering the target, which I think generally works there. But the discovery proxy and finding the intersection of the set of proxies that the client will trust and the set of proxies that the target will trust is challenging. And because there's no discovery mechanism for the proxy pieces, the information the client has is insufficient based on your current design. I think we need a little bit more about that, to Ted's point earlier. So I think we probably need something more. I found the draft to be quite confusing on that front, because thinking as a client, I saw a URL, but that's not the URL that I can use. I need two of them in order to make a request with Oblivious HTTP, and you only gave me one of them. So I think there's probably another round before we go there.
Yeah, I mean, to respond to that, I think the existing model without discovery for either proxy or target is essentially you need some proprietary mechanism for learning the configurations and learning what your proxy is and what the paths are that map to your target. So a lot of this is, and I should clarify it, assuming that you still have that proprietary mechanism to communicate what the config of the proxy is to the client. And that essentially the client and proxy can learn, can negotiate what they support and what the paths are, etc., and learn whether or not this target is supported. And a new mechanism to have that relationship between a client and a proxy that is generic, I think is a larger scope and is less clear to me.
Yeah, so probably the other idea that I had here was, if you get a URL for the target resource, there's a bunch of things you can do by talking to that target resource. in terms of learning what proxies it trusts and learning what its config is. That, of course, creates some interesting issues when it comes to consistency. But those are the issues that I think we need to be thinking through here.
Chris?
Hi. Yeah, Chris Box. I work for BT. I just wanted to say I think this is a really interesting idea. It allows an ISP to offer DNS-based services in a way that doesn't require exposing the client's identity. So, for example, an ISP could offer malware filtering, for that service. We don't need to know who made the request. So I take the point of others about, we need to explore all the implications of it, but I think it's a good idea, and I'd like to see it adopted.
All right, thank you. Yeah, definitely. Let's work on the problem, is what I hear, and fix the solution. All right. Eric?
Yeah, very, very similar to the last comment, actually. I think this is a very good problem. I like the overall solution. I like the overall area to solve. I think this is something we should be adopting. I think the only question is, do we solve the very big security issues that I agree with almost everything I've said in those areas already? Do we solve those before we adopt it, or do we adopt and write out the solutions for them? And I don't think they're too hard of security issues to solve. We've had a lot of talk in the chat about, hey, signings of all this. The draft already discussed a little bit, linking the consistency draft for stuff about the other one that Ecker was discussing earlier. So I think if we beef up the handling for the security implications, this is a very good draft to have. So I mean, I'd say let's adopt it and do that beefing up.
Great. And what I would say is, besides stuff on the list, there is a GitHub for this. And so Eric and Ben and Ecker, if people have ideas, let's work on them and try to revise this. We can turn out another version of the draft quickly. And if that's something that people like the solution on more, then that would be a good adoption target. All right, I think that's the cue. Oh, Ben.
Ben, did you have any last comment there?
If there's time, I'll say, I do think that to step back one more step, I think that we need a little bit more of an integrated architecture approach here. That figuring out what makes sense here really does depend on how we decide to handle key consistency. For example, it depends a little bit, as some other folks were saying, on how users are learning the initial URL that got them to this query. So I think I would like to see us step back a little bit and see if we can put together, a set of puzzle pieces that really fit together into a clean overall solution.
Jigsaw puzzle, one might say. Yeah, so I've been chatting with my co-chair in the background here. It seems like where we're ending up here is that there's some energy behind this being a problem that is useful to solve. But it sounds like the draft is not yet in a state where it's kind of adoptable, and there's enough energy around the drafts in particular. So I think the message there is to kind of keep refining the problem statement, and especially around the security requirements. And I think we can look at whether a future draft would align with that better. All right. I think that brings us to the end of our agenda. Siobhan, is that correct?
Yes, we do have about 15 minutes left, I think. We can just let everyone go early, unless anyone has anything they'd like to say, or we do have like buffer time. I don't know if anyone has any comments. I guess something that we did want to ask, Richard, was that it seemed like there were at least a few issues that were pretty, I guess, hotly discussed. So we were wondering if folks would be interested in having virtual interns. The shadow banning case, I think, was the specific one you were thinking about, but maybe for some of the other ones as well. So if folks would be interested in that, I mean, please let us know. Yeah, go ahead, Martin.
I don't know. Long and Meet Echo takes forever to unmute. I think, given the feedback that we got on the shadow banning case here, I have a pretty good sense that we can come to a conclusion on some text that will work for it in the next, I will say, weeks. The anti-replay stuff is maybe less settled, but I suspect we can make some good progress on that on the list. The discovery issue does seem to be something that is worth spending a bit of in-person high bandwidth time on. So if there's any topic that rises to that level, I think that's the one.
That makes sense. So it sounds like we maybe don't need to schedule a virtual interim right now, but if we get to a point where we're ready to have some deeper dives on those latter two topics, we chairs would be happy to do it.
Yep, that sounds right. Francesca, anything you want to say?
No, sounds good.
Okay, perfect. All right, then thanks all for coming, and see you all on the list.
Thanks everyone. Class dismissed.
Thanks again, Francesca, for helping out.
Thank you, and thank you, the minutes taker as well.
Yes, thank you.
Yeah. Yes. Also, the problem is this time slot being right before the plenary, the three big rooms are closed because they're reshuffling them to prepare for the plenary. It's already set down. Oh, yeah. Well, I mean, just you can't say